So this one is exercise related to chemical energetics, energy from the chemical. The first one, which quantity is exothermic? So what could be the answer? Which quantity is exothermic? So when we work out enthalpy change of atomization, atomization means energy required to produce atoms in a gaseous state. So we have to supply energy, like sulfur is solid, energy required to convert sulfur into gas. So that is endothermic. This cannot be an answer. First, ionization. Ionization energy means energy required to remove the electron from the neutral gaseous atom. So sulfur belongs to group 6. So first shell it will have 2 electron, and the second shell it will have 8 electron, and the third shell it will have 6 electrons. So energy required to convert this sulfur gaseous atom into sulfur ion, positive ion, that's endo as well, because we have to supply energy to remove electron. Electron affinity. Electron affinity means when electron is added. So when electron is added to a sulfur, like we have a sulfur in a solid, in a gaseous state, electron is added, so it will become a negative charge. So what it will it will release energy. Second electron affinity will be negative, will be endothermic, will be positive. Why? Because now the sulfur is already minus charge and we have to add electron. So to add this electron we have to supply energy, because the like charges repel each other. That's why the second electron affinity will be endothermic. So the correct answer is option C. The following statement give information about the thermodynamic stability. Magnesium chloride is stable with respect to magnesium and chlorine. Means when we have a magnesium, to have a higher stability, when we say that it's having a higher stability, it means it will, the energy will, it will have a lower energy, or the product is having a lower energy. Yeah, that's right. Iftikhar C is the right answer. Magnesium reacted with chlorine to form 1 mole of magnesium chloride in a solid state. Because they mention it, magnesium chloride is stable with respect to magnesium and chlorine. So it means that this is having a low energy. The magnesium chloride MgCl will have lower energy as compared to MgNCl. So if lower energy, it will be exothermic. MgCl is unstable. If it is unstable, the magnesium react with respect to MgCl2 plus Mg. And MgCl3 is unstable with respect to magnesium and chlorine. So this one is unstable. Unstable means it required energy. So there should be input energy to form this. Then this will be endothermic. That's why C is the right answer. When we say they are more stable, so means they have low energy. And if we say less stable, it means the product is having a high energy. And if the product is having low energy, the reaction will be exo. If the product is having high energy, then the reaction will be endothermic. So enthalpy change for formation of MgCl will be negative, but MgCl3 will be positive. In this question, when 10 cm cube of nitric acid reacted with 20 cm cube of sodium hydroxide, the temperature rise to delta T. This is delta T. Now using 15 cm cube of same nitric acid and 30 cm cube of sodium hydroxide would give a temperature rise of, so how much is the temperature rise? What will be the temperature rise? What could be the answer for this? Keep in mind the relation between the temperature. We have the formula E is equals to Cm delta T. This is the formula E is equals to Cm delta T. So the temperature change is E divided by C Nm. Now, first what we did, the total volume of the solution, that was 10 and 20, so total volume was 30. In the second one, this is 15 and 30, so this is 45. The mass increases as the volume increases, the mass of the water increase, and the mass and temperature change are inversely proportional. But what about the energy, the amounts, the total? Because when you compare the total amount or the total change in amount, or to 10 cm cube of nitric acid react with 20 cm cube, and the reaction is repeated using 15 cm cube of nitric acid and 30 cm cube of sodium hydroxide. So what we did, this is 1.5 times, this is also 1.5 times. So if we increase the amount, energy release will also be, specific heat is constant, so energy and temperature change are directly proportional, and mass and temperature change are inversely proportional. So what happened to mass? The mass increases by, because the original mass was 30, the new mass is 45. So mass also increases by 1.5 times. So temperature change will decrease by 1.5. But due to the amounts, as we increase the amount, energy release, because the total amount which we use is 1.5 times the original one. Like it was originally 10, now it is 15. So it means we increases the amount 1.5 times. So if amount or increase 1.5 times, so energy increase will also be 1.5 times. So if energy increase 1.5 times, the temperature also increase by 1.5 times. So due to the change in the due to the energy change, it will increase by 1.5 times, and due to the mass change or increase in mass, it will divide by 1.5 times. So both will cancel out, the both changes cancel out each other. That is why the temperature change will be same as what was there when we were using 10 cm cube of nitric acid with 20 cm cube of sodium hydroxide. Is it clear? So they basically cancel out the effect of each other. The enthalpy level diagram for a reaction is there. Which row of a table shows the correct term for X and Y? What is X, what is Y, and what is the enthalpy change of this? Is it an endothermic, exothermic? What could be the answer? So C is the right answer, because X is showing the reactant and Y is representing a product, and the enthalpy change is for endothermic reaction. The table shows the mean bond enthalpy for some covalent substance. What is the approximate enthalpy change in kilojoule per mole? So basically the bond breaking energy minus bond forming energy is equals to energy change. So bond breaking, we are breaking carbon-carbon double bond, 612. We are breaking CH bond, 1, 2, 3, 4. So 4 multiplied by CH, that is 413. And we are breaking Br, bromine-bromine bond, 193. That's a bond breaking. Bond forming, we are breaking carbon-carbon, so 347. We are breaking CH bonds, 413. and we are breaking CBr bonds 290, but they are multiplied by 2. So that is a bond forming energy. This one is a bond breaking. To get the enthalpy change, it is bond breaking minus bond forming. So what's the answer for this after doing the calculation? The bond breaking minus the bond forming. So question 5. So B is the right answer, minus 122 kilojoule per mole. Okay. In this question, 6A and B, two parts are there, A, B and C. Some energy changes involved in Born-Haber cycle. Born-Haber cycle is basically an application of Hess law. So some energy change involved in a Born-Haber cycle: electron affinity, lattice energy, standard enthalpy change of atomization, and standard enthalpy change of formation. Which enthalpy or enthalpy energy change is represented by P? So what is represented by P? A, B, C or D? Because we are converting a solid into a gaseous state, so we call that as atomization. That's why C is the right answer. Then elements are forming a compound. Potassium and chlorine are forming a compound. What we call this enthalpy change when element form a compound? Yeah, that's right. It's a formation, so formation D is the right answer. Then what we are doing, we have a chlorine molecule and we are producing a chlorine atom. What we call this enthalpy change? So this is also atomization, because when we produce atom in a gaseous state, we call that as atomization. Okay, in this question, what we have to do, calculate the value for enthalpy change in kilojoule per mole for the following reaction. Carbon react with oxygen, give carbon dioxide. Lead react with oxygen, give lead oxide. And lead oxide react with carbon monoxide to form lead and carbon dioxide. And using these values, what we have to do, we have to calculate the enthalpy change for this reaction. So how we can work out the enthalpy change for this reaction? So we have to make a cycle. According to this, we have to make a cycle. So how we can make a cycle here? Like if we have lead oxide, and carbon monoxide, it produces lead and carbon dioxide. So lead oxide plus carbon monoxide, what it result? It gives lead plus carbon dioxide. Now, what is the other possibility? If we add a link here, like example, we have carbon react with oxygen, it can produce carbon monoxide, or carbon dioxide reacted with oxygen, it will produce carbon dioxide. And lead is there because how the lead oxide is produced. So maybe we have an element, lead is there, lead react with oxygen, it will produce lead oxide plus carbon monoxide, or here the lead will remain as it is, no changes there. So we have lead and oxygen is as a reactant here and oxygen as a reactant for other side. This is one way. There is also another way. What is that way? That is called a simultaneous equation. Like you have these equations and you want to get carbon, oxygen and carbon monoxide. So it means you want to remove all other from this. So how we can remove all the other things? First thing, if I name this equation 1, 2 and 3. So I don't want, in the final result, I don't want lead or I don't want lead oxide. So first what I will do, if I will add equation 1 and 2. So if I add equation 1 and 2, it means the lead oxide will cancel with lead oxide, lead will cancel with lead, and addition of this, what it result? The equation which we will have carbon monoxide plus half oxygen gives carbon dioxide. This is the equation which we will get. Now we have this equation, so and we are adding these two. So minus 217 and minus 66. So that will be minus 283 kilojoule per mole after adding equation 1 and 2. And then we have carbon oxygen gives carbon dioxide. So in the equation we don't need carbon dioxide. So we can use this equation and we subtract, like we have the first equation now. This was not 1 and 2, this is 2 and 3. If I add, now subtract this from equation 1, or I can rearrange and add, because I want to remove the carbon dioxide. So if I rearrange this equation, if I completely change the reactant with product, so I can say carbon dioxide is equals to carbon monoxide plus half oxygen, and the value will also change, it will be 283 because I completely flip the reactant with product. So we have this equation, and the first equation was carbon plus oxygen gives carbon dioxide. So when they are in opposite side, if I add them now again, so carbon dioxide will cancel with carbon dioxide. So here we have carbon, oxygen minus half oxygen. So we are left with half oxygen and it gives carbon monoxide. This value was minus 394. So when we solve this, we'll get minus 111. So answer for this one will be B. So this is one way, like using a simultaneous equation, we can solve this question. This is one way of solving the equation. And there's also another way, as we can make a cycle here. When carbon react with oxygen, so basically it is a formation is given. When lead oxide react with oxygen, so this is also a formation is given. And carbon, this is the enthalpy of reaction is given. And we need, say this is delta H2, this is delta H1. So what we have to make, and this is the enthalpy for formation of carbon monoxide is given. So what we can do, we can add a link here, like, because this is the formation of carbon monoxide. Maybe carbon react with oxygen, it will produce carbon dioxide, and this formation of the carbon dioxide reacted with, or there's a lead element, so we have a lead oxide, because carbon react with oxygen give carbon dioxide, lead reacted with oxygen give lead oxide. But the lead oxide should form the other side. Reason for that, because we have this equation, lead oxide plus carbon monoxide, so we have lead oxide in this side. This will be Pb. And then what happened? How we can link the carbon plus oxygen give carbon dioxide? That's already there. And lead oxide plus carbon monoxide, what it give? It will give lead plus carbon dioxide. So you can see this is a start of the cycle where two arrows are pointing out, and this one is the end of the cycle. So just substitute the value for enthalpy change and work out this plus this equals to this. Means this one is how much? Carbon react with oxygen give carbon monoxide, so this is X unknown for us. Lead reacted with oxygen form lead oxide, so lead reacted with oxygen form lead oxide, that is minus 217, and carbon monoxide and lead oxide react to form lead and carbon dioxide, that is minus 66, and carbon dioxide formation is minus 394. So when we apply the Hess law, so X minus 217 minus 66 is equals to minus 394, because the two arrows are pointing out start of the cycle, this is the end of the cycle. When we move other side, we'll get the same answer, minus 111. Is it clear? Then which of the following enthalpy change cannot be measured directly? Basically, experimentally, it is difficult to find for endothermic reaction, because we have to supply energy and we want to make sure that all of the substance break down or decompose. So which one is a difficult one to measure directly? Formation of methane, that's right, because bond forming, how methane is formed? When combustion of hydrogen exo, formation of carbon dioxide exo, combustion of carbon monoxide also exo. So in this one, it will be difficult to measure directly. The standard the standard enthalpy changes of formation of ethene is 52 and that of ethane is 84.7. Calculate the standard enthalpy change. So when formation is given, what we will add, we'll add a link, that is elements. So in this one we have to add the link, and what link we have to add? The element. And the possibility is that the element will form the reactant form the product, or the element directly form the product when formation is given. So here the element which are there, carbon in a solid state, hydrogen is there in a gaseous state. So here it will form ethene. To form 1 mole of ethene, how much energy is there? 52.2. This is unknown X. And to form propene, formation of the propene is given, that is 84.7 negative. But for hydrogen is not formed here, because before and after you have the elements of formation of element here 0. So when you apply the bond here, the Hess law, So the two arrows are pointing out, that is a start of the cycle. Two arrows are pointing in, that is end of the cycle. So when we follow route 1 or we follow route 2, the energy change will be same. So it will be 52.2 plus x is equals to minus 84.7. This is minus 84.7. Other side, the 52.2 is positive. Other side it will be negative. So 84.7 minus 52.2. So answer for this one will be 36, negative 36.9. That is the enthalpy change for hydration of this, or enthalpy change of the reaction. Is it clear, this one? So whenever in the question formation is given, what we add a link, that is element. And element form the reactant and reactant form a product is same as element directly form the product. If in the question combustion is given, so you will have a combustion product of the combustion here. So element burned produce that combustion product can burn and produce the same combustion product. Which of the following equation represent a reaction for which enthalpy change is the standard enthalpy change of formation of water? So the term formation means when element form a compound. So which one is the right answer for question 10? When element is forming a compound, that's called enthalpy change of formation. Yeah, B elements are for here ions are forming compound. Here this is water, gas and vapor. That's not there because the definition is element form 1 mole of a compound. We call that as enthalpy change of formation. By considering the following enthalpy values, carbon monoxide bond enthalpies are given. What we need the answer for complete combustion of carbon monoxide. So first thing, even when you are looking at this, because the reaction is a combustion reaction and combustion reaction cannot be an endothermic. So without calculation, I can write an answer that I can say A will be the answer. Why? Because this is a burning of carbon monoxide. So burning is always exothermic. So I should get a negative answer. Rest all options are positive. That's why A is the right answer. In endothermic reaction in aqueous solution, which of the following is correct? Endothermic reaction, what happened to temperature? They mean temperature of the surrounding, and what is the value for the sign for enthalpy change? Question 12. Yeah, C is the right answer because surrounding temperature decreases and enthalpy change will be positive. The enthalpy change of a reaction to form a hydrated sodium thiosulfate crystals cannot be measured directly because it's an endothermic. Following Hess law cycle can be used. Enthalpy change delta R is equal to, so how we can work out where the two arrows are pointing out, that is the start of the cycle. And the two arrows are pointing in, that is the end of the cycle. So when we follow a route 1, so if we follow route 1 or we follow route 2, the overall energy change is independent of the route which we follow. So delta HR, the enthalpy of reaction, plus delta H2 is equals to delta H1. But we need delta HR, so H2 will go other side. So it will be delta H1 minus delta H2. In this question, when 10 cm cube of 2 mole per dm cube hydrochloric acid reacted with 10 cm cube of 2 mole per dm cube sodium hydroxide, the temperature change is delta T. The experiment was repeated using 50 cm cube of each solution. What will be the enthalpy change? What will be the temperature change? So again, what you have to do, you have to find a relation between the energy and the temperature change, and we have E is equals to Cm delta T, or E divided by M delta T is equals to C. So means temperature change is directly proportional to energy, and it is directly inversely proportional to mass or the volume of the solution used. So what was the volume of solution used? 10 cm cube of hydrochloric acid. So originally it was 20 cm cube. And now when the reaction is repeated with 50 cm cube of each solution, so if 50 cm cube of each solution, the total volume will be 100 cm cube. Now if 100 cm cube is the volume of solution, the mass of the solution will also be 100 grams. So compared to 20 gram, now it is 100 grams. So it means the mass is increased by 5. So mass is increased by 5, the temperature change should decrease by 5. So due to change in the mass, the temperature change decreased by 5. But the energy and temperature change are directly proportional. What about the amounts? When you check the amount of solution also, it becomes 5 times. So if the amount of solution, the number of moles also, like what will be the moles in this, same 5 times will be the moles. So this will increase by 5, this will also increase by 5. So overall change, one is divided, another one is multiplied. So overall change will be same, or they cancel out each other. The temperature change will be delta T. Then question 15, in an experiment, to measure the enthalpy change of a reaction involving the gases, which of the following conditions must be kept constant? So if we are measuring the enthalpy change, so we should keep the pressure. Look, if we are calculating enthalpy change, so temperature, we cannot keep the temperature constant. Why we cannot keep the temperature constant? Because using a temperature, we will work out how much energy will be there, released or absorbed. So temperature cannot be kept constant. So anything which involves temperature cannot be an answer. Then what happened? The thing which we should keep as a constant is the pressure. Because if we change the pressure, and volume are inversely proportional to each other. But if we change the pressure, we can change the temperature as well, as temperature and pressure are directly proportional. That is why we should keep the pressure of the gas constant. So experiment to measure the enthalpy change of a reaction involving the gases, which of the following conditions must be all kept constant, always kept constant? The pressure should be kept constant. No, pressure will be kept constant, but what happens? The volume will change as the temperature changes. As we know, according to Charles' law, that the volume and temperature are directly proportional to each other. So how we keep the pressure constant? By keeping a same or a constant force. Example, a 10 Newton force on a unit area. So when the reaction occurs, if it's an exothermic reaction, it will release energy, temperature increase, so the volume will also increase, but keeping the pressure constant. If you try to keep the volume constant, then you have to increase the pressure. So these are questions related to chemical energetics. Next session will continue with more questions related to this topic, as well as the weekly homework I'll discuss next week. So I'll end the session and share this recording with you.